Hello. This is the 5th time I've tried to do this part of the video, so I hope it works. What is the initial amount, growth rate, and domain and range? A population, f of x, so that's people, after x years, that means it's time, may be modeled by this equation. This right here is our initial value. This right here is going to be our growth rate. Our domain. We're talking about years. You cannot have a year in the negatives. Our range. Well, if this is the smallest x value, we've got to plug that in. So f of 0 equals 2 times 3 to the 0 power. Well, that's 2 times 3. No, it is not. It's 2 times 1, so it's 2. So y is greater than or equal to 2. We are skipping this one. Whitney invests $3,000 in an account earning 4.5 interest that is compounded annually. How much money will be in Whitney's account after 10 years? So that equation is A equals P parenthesis 1 plus R over N T. So our starting amount, I don't know why I did that, equals the principal amount. How much did we start with? 1 plus. Now this says it's compounded annually. So how much does it get compounded each year? 1 time. So I'm not going to divide. My n value is 1. Anything over 1 is that same number. So I'm just going to put this. And then 1 times t is just going to be t. Now, would I accept it as this right here? Of course, because it means exactly the same thing. Now, if I can get my calculator to work, then we're going to do 3,000 times 1.045 raised to the, and it says 10 years, and I get $4,658.91. Attendance for the local baseball games has been increasing by an average of 10% per year for the last few years. In 2018, the average attendance was 100 people. We're talking about people, boys and girls. So that means y is going to equal 1 plus our rate raised to the t. So how much did we start with? How many people did we start with? We started with 100 people. 1 plus, what's the rate? The rate is 0.10. We know what t they want, but right now that's what we have. Or you could write it as this. Now we're going from 2018 to 2022. That means my t value is going to be 4 years. So if I plug that into my calculator, so 100 times 1.1 raised to the 4th power, it comes up with 461.41. Well, guys, we can't have partial people. So it's only going to be 146 people. This next one wants us to write explicit and reoccurring functions. How about recursive? Okay, so here we go. Well, it's going positive, negative, positive, negative. automatically is not going to be arithmetic. So let's see. Negative 50 divided by 100. That's going to give us times by negative 1/2. These two times by negative 1/2. Yes. This times by negative 1/2. Oh, yes. So that works for all of these. So that means my ratio is negative 1/2. So a sub 1, or a sub n equals a sub 1, which is 100, times negative 1.5 raised to the n minus 1. Remember, when it's talking about a sequence, you're starting with the first term, not the zero term, so you have to have the n minus 1. So this is our explicit formula. So now we're going to write the recursive formula. A sub 1 equals 100. A sub n equals negative 1/2 times, I don't know why I wrote it like that, a sub n minus 1, so the previous term, if n is greater than or equal to 2. So the term has to be the second term. Then this one. Okay, looks like we're going down by 15 each time. So that means my d value is 15. So a sub n equals, where did we start? We started at 20. We went up by 15, n minus 1. Now, you could also write it in the simplified form of 15n plus 5. So either one of those would work for your explicit. Your recursive is the a sub 1 equals 20, where a sub n equals the first term, not the first term, nope. The previous term plus 15, and we're talking about starting at the second term. So that's our recursive. Same thing here. Add 2, add 4. Oh, it's not arithmetic. Okay. So it's also times by 2, times by 2. Okay, so this is going to be geometric. So that means my R value is 2. So a sub n equals the starting value, which is 2, the rate, which is 2, and n minus 1. So this right here is my explicit formula. My recursive formula has to be a sub 1 equals what? 2, where a sub n is equal to 2 times the previous term, and you have to start at the second term. This one. This is going down by 0.6. That's definitely going down by more. So that means I need to do 5.4 divided by 6. That's going to get me 0.9. So if I multiply it by 0, nope, not. Zero's in the wrong spot. Oh no, I was doing the right thing. This one, yep. I'm multiplying each one of these by 0.9. So that is what my R value is. So a sub n equals my starting value, my rate, to the n minus 1. My recursive formula, a sub 1 equals 6, where a sub n is equal to 0.9 times the previous amount, and we have to start at 2, the second term. There we go. So this next one. Now, I told you guys you didn't need to do the explicit formula for these two problems, you're just going to be doing finding the terms for those two. But you are going to be finding either the explicit or recursive for the other ones. So the first terms. So the first term is -2. So if I plug this in, 2 times -2 plus 5. So that's -4 plus 5, so that's 1. So I'm going to put a 1 in here. 2 times 1 is 2 plus 5 is 9. And if I put like 9 in there, that's 18 plus 5. That'll get you 23. 1, 2, 3, 4. Oops. Did I do that right? 1. 1 times 2 is... I did not do that right. I knew those numbers were looking a little weird. Let's do this again. -2. That would be -4 plus 5, which is 1. Now, if I plugged in 1 here, that would be 2 plus 5 is 7. There we go. 7, that'd be 14 plus 5. 14 plus 5 is 19. That'd be 38 plus 5, 43. Okay. This next one. Our starting value is 3. And we're going to go up by a rate of 4. So, multiplying by 4 each time. So that'll get me 12. That'll get me 48. So 96. I think the next one... Oh, that is not. I times it by 2. 192. There we go. That looks better. And then times that by 4 and get 768. There we go. Now, I need to also write the recursive formula. So a sub 1 equals 3, where a sub n equals 4 times the previous term if n is greater than or equal to 2. Okay, so we're going to come over here. Tells us that 38 is where we're starting at. Tells that we're going to multiply by a half each time. So that'll get 19. 19 or divided by 2, it's going to be at 9.5. Since I've messed up so many times, actually going to divide or use my calculator. 4.75, then 2.375. Okay, so then I need to write my recursive. So, nope, my explicit. So my explicit would be, start out with 38, multiply that by a half, and raise it to the n minus 1. Okay, over here, let's see, we'll use pink. So my first term, so I need to plug in 1. If I plug in 1, I get 45. If I plug in 2, I would get -14. -14 plus 52. And get 38. Do you notice how it's just going down by 7 each time? That's what this means. This is my D value. It's your slope. It's your D value. So you're subtracting 7 each time. So we would get 31. Subtract 7 to get 24. Oops, I did it again. 24, subtract 7 again, and get 17. Then if I'm going to write my recursive, my a sub 1 equals 45, where a sub n equals the previous term, subtract, oh, that was weird, subtracting 7, and that's if you start at n is 2. This one, it is in an explicit, or it's in a recursive. We need to write it in explicit, and we need to write the term. So negative 2, and we're going to subtract 12. So negative 14. Subtract 12, negative 26. Subtract 12, negative 38. Subtract 12, negative 50. So if I'm going to write my explicit, I have a sub n equals negative 2 plus, oh no, we're subtracting n minus 1. Now if you have it in the simplified form, it would be negative 12n plus 10. I don't know why I did that. It should be around both of those. And then last but certainly not least, we are starting at 13. We are negative 2 times 13 minus 3. So that's negative 26. Negative. That was weird. Negative 26. Minus 3. Why did I use a calculator for that? Negative 29. So then I would plug in negative 29 here and multiply that by negative 2 and subtract 3 and get 55. And take that and multiply it by negative 2 and subtract 3, get negative 113, and take that and multiply it by negative 2 and subtract 3, 223. Okay.